This is the tutorial for the study guide, solutions for the study guide for chapter 4, sections 1 and 2. So let's take a look at the first problem that we'll end up seeing, and it says y equals negative 2x plus 3. So what we want to first of all look at is trying to graph this line, maybe using a couple points. And actually I'm going to use more than a couple, I'm going to use 3 points. And so I'm going to start with my function, which is negative 2x plus 3. And then I'm going to come up with y values. And so my values I'm going to pick are going to end up being a negative value. I'm going to pick negative 1, 0, and 1. And so I substitute negative 1 back in for x, multiplying it by negative 2, and then adding 3. So that makes 2 plus 3 gives me 5. So what that is an ordered pair. The ordered pair says that I go over one space to the left and up 5 spaces. So 1, 2, 3, 4. 5 would be up a little bit higher than the graph has. So the next point, 0, I plug in for x, and I do negative 2 times 0, and then I add 3. And so when I do that, the 2 times 0 just makes 0, so 0 plus 3 gives me 3. So over 0 spaces, up 3, puts me right there. And over one space, well, I take negative 2 times by 1 and then add 3. So it makes negative 2 plus 3 gives me 1. So over one space, up one space. So I can see the line is heading downhill from left to right. That's what we end up getting. So that is the first one. Let's take a look at our next. It says graph and label both linear equations on the same coordinate plane. So that's what the brace tells us. We'll see that later on when we're dealing with systems of equations. We'll have the brace between two equations, and they want us to do exactly what they said, graph on the same coordinate plane. And the solution would end up being where the lines cross. But for right now, all we're doing is graphing this. So whenever we see an equation where there's no x, only y, what we have is a horizontal. So we have a horizontal line. And if we have this problem here, it has y is 3. So what that means is no matter what, if I pick any x value, I would end up multiplying that x value by 0, because that's why we don't see that value in there, and then adding 3. So no matter what the y value or x value is, negative 1, 0, 1, when I do this work, I always end up with 0 plus 3. So you can see the y is always 3. So this is a function of x, just like the last one was, and the function always yields 3, so it looks like this. I went ahead and plotted these points over one space up 3, over 0 up 3, over 1 up 3, and you can see how you get that horizontal line. Be sure to label that graph y equals 3 so I know which one is which that you're talking about. And taking a look at the next one is actually a function of y, because it says we don't see any y value, only x. And so that means we have a vertical line. And so if we were to graph this one, you see the x values are always held constant. So this is a function of y, because I'm having to substitute y values in and then subtracting 2. So they're giving me the x value this time, and I have to substitute in y values. So I'm going to pick these values for y, and you can see how every time you end up with 0 when you multiply whatever y value you pick. And that's why we always get x at negative 2. And so in this case, no matter what, the x value is negative 2, and so that would look like this. Y value go up 1, you go over, not 1, but 2 spaces. Let's fix that. And over 0 up 2, or over, up 0 over 2, up or down 1, we go over 2 to the left. So you can see how that's going to end up being that vertical line. And so make sure you label that x equals negative 2. So moving on to the next type of problem, it says that the cost, y in dollars, for making bracelets is this. Okay, so y is the amount in dollars. So that's our cost. So we're going to label the graph with that. So we're going to put a dollar sign here. And we'll say this is the cost. So So this is the cost labeled down in this region here. And then I'll go ahead and draw in a y-axis here. So that represents my y-axis, the cost, and then my x-axis is going to end up being the number of bracelets, because it says that, where x is the number of bracelets. So I'll put in number of bracelets. So now what I want to do is graph the equation. So they give me this formula here, and so I'm going to go ahead and set up an expression. So this time typically I start with a negative, but we can't have negative bracelets. That doesn't make sense. So we start off with what we could have. And what we could have is 0 bracelets. And so if we have 0 bracelets, we multiply 0 times 0.5 gives me 0 plus 2 gives me 2. So for 0 bracelets we have 2. And I'm going to go up by just ones here. So this is like 2, 4, 6, 8. So that way I know, I can tell the reader what that number represents. Over here I'll do the same thing. 2, 4, 6, and 8. Sometimes I'll change those units depending on how big the numbers are. In this case they're not very large, so I can just go up by ones. So what happens if I have 2 bracelets? I could pick one. Actually, I'll go ahead and do that for now. 1 bracelet would make 0.5 plus 2 would be 2.5. So 2.5 would be x. And then so you can see how if we just went by 2's, I wouldn't end up having the decimal, because 2 times a half makes 1. And then plus the 2 gives me 3. So I'm going to go with going by 2's now. So 4, half of 4 is 2, plus 2 makes 4. And that way I don't have to deal with the decimals. So I would have a point here, so over 2 spaces, up 3, over 4 spaces, up, let's see here, over 4 spaces, up 4, that's right, and then over 6, let's see what happens with that one. Half of 6 is 3, 3 plus 2 makes 5. And so over 6, up 5. So you can see how there's a constant rate of change, and that always yields a pattern. So you can see as I go up by 2's, it just goes up by 1's each time. So how many bracelets can be made for $10? Well, $10 is the cost. And so I'm using this equation, y equals 0.5x plus 2. So I put $10 in for y. I have 0.5x plus 2. So I'm going to subtract the 2 from all sides, and I'm left with 8 equals 0.5x. So I divide by 0.5, and when you divide by a decimal, that decimal moves over 1 space, you add a 0, and then you do the division. 5 into 80 goes 16 times, so 16 bracelets. 16 bracelets for $10 is the explanation there. So let's move on to the next type of problem, and it says that we have to draw and label a line with no slope. And so when we saw on the last problem, we talked about a vertical line. And a vertical line has no slope. Has no slope. And so the reason is this: when I go ahead and draw a line that's vertical, this is one that has no slope. And so I would need to label that. This is the no slope. And so it's no slope because notice if I went ahead and picked these 2 points right here, I'm going over 0, but I'm going up 1. So this would be this slope for this vertical line. Vertical line would end up being, I had to rise 1 but ran 0. So this would mean that I have 1 part of nothing. And you can't have 1 part of nothing. In order to have a part, you have to have something. And since I have nothing, I can't have a part. And so that's why we say the slope is undefined. We have undefined slope in that case. So that's what that represents. Now, a slope of 0 is a horizontal line. So we'll say a horizontal line has zero slope. And so when we're doing that, I'll just draw a line here. So this would be our answer right here, but make sure you label which one has no slope. So the vertical line had no slope, this one has 0 slope. So make sure you label that for me on the test. And the reason it does is if you look at 2 points, like these 2 points right here, notice how for the horizontal line, we ended up going in the y direction up 0 over 1. And this means that I have no parts. I have 0 parts. 0 parts of 1. And I can have that. That's like having no pieces of pizza if I had one pizza. And you can do that. So that makes sense. That is a slope of 0. So that is 0, 0 slope. So here they're asking us to find the slope of the line. So when I find the slope of the line, I can start at the left-hand point and count the spaces. 1, 2, 3, 4. So I went up 4 spaces. And that represents a positive 4. So remember, the slope equals the change of y. Change of y. So I'm going in the y direction up 4 spaces. And then I changed in the x direction. I went right 2. And so again, the slope is the change of y over change of x. And so I went right 2. And those are both positive values. Up 4 represents a positive 4. Right 2 represents a positive 2. And so that's why I have 2 positives, and that slope would reduce down to just 2 over 1, or just 2. And that would be the answer. The other way of doing it is to set up the formula, y minus y1 over x minus x1. And you could subtract the 2 y values. I could do 2 minus negative 2. So I took from these 2 y values, and then I do, since I started with the positive 2, I got to start with the 5 minus 3. And you see when you add the opposite, you end up with 4 over 2, the same exact answer. So 2 ways to solve that. Look in the next one. It says the slope of the roof is referred to as the pitch. Here counting requires a pitch of at least 1 to 2. So at least means that amount or more. So it has to be that amount or more. So 1 to 2, this in a form that way is the same thing as showing it as a fraction like this. So the slope has to be greater than or equal to. So 1/2 has to, the number ends up having to be bigger than that value. And so actually I'm going to go ahead and show it a little bit different here. So I'm going to end up showing this a little bit different. I'm going to show it as that I want the value that I'm going to come up with to be greater than or equal to this value. So I can take a look at this slope, and it is the rise over the run, 4 over 12. And you can notice how we can reduce this fraction by taking out a common factor of 4, and I would end up with 1 over 3. So I need to find out which one's bigger. Is 1/3 really greater than or equal to 1/2? So let's go ahead and multiply by 2 over 2 to come up with the common denominator, and I have 2/6. And is that greater than or equal to 2/4 or 2? I should multiply this by 3 because I need to multiply by the other's denominator. So let me fix that real quick. So I multiply this by 3 over 3, and this makes a 3 over 6. And you can see how that's not true. So it does not, I will say the roof, does not meet county specs because it is less, or we could say the slope is because the slope is less than 1/2. So let's move on to the last type of problem we'll see, and here we just have to solve an equation. So we're distributing, so we have 3h minus 21 equals, then I distribute over here and I have 20 plus 2h. So I'll just subtract that 2h from both sides. That leaves me with h minus 21 equals 20. So from there I just have the one step of adding 21 to all sides, and I get h equals 41. On this one, I have to describe the translation moving from ABCD to the A prime, B prime, C prime, D prime. And so I'm going to look at the D prime for right now, and I'm going to count the spaces to the elevation of the D prime, from D to D prime. So I go down 1, 2, 3, looks like 3 down. So 3 spaces down, and then I count the spaces over. So 1, 2, 3, and then I count the spaces to the left, and it's 1, 2, 3, 4, 5, 6, 7. So 7 left. And so you can also write it using the formula method, and that would be x minus 7, comma, and then y minus 3. And that would also work as well. So the last one says the ratio of side length of square A to side length of square B, so A to B, is 5 to 8. And it says the perimeter of B is 96. So that's why I put 96 down the bottom. And they want to find out what is the area of square A. So area means that I need to figure out what the side lengths are. And these are perimeters now here, and on this side it's side lengths, at least the ratio of side lengths. Now the ratio of side lengths doesn't mean that's the length of the side, it just means that that's what they reduce down to. So I'm going to cross multiply to solve this. And when I divide by 8, I see 8 goes into 96 12 times, so that makes 60 is the value of x. But this is the perimeter of square A, not the area. So what I need to do is, again, what that is if we look at the square A, it's the distance going around it. So I know that all the sides are the same. This is like side length, side length, side length, side length. I need to find out what that is. So if I divide it by 4, that ends up giving me 15. So now I know, okay, the side length's 15. So it's 15 all the way around this image. Well, to find the area, so this is the side length, and so to find the area, I'm just going to go ahead and multiply 15 times 15, and that gives me 225. These are yards, so yards squared. That's the area of square A. So those are problems you'll see on the test. Good luck.